So in this video, we're going to be finding the ambiguous case. That just basically means the angle. You're going to be given two sides and an angle of a triangle, and it'll be in the form of side, side, angle. So like this, side, side, angle, side, side, angle. And so what that happens is sometimes we get one answer, sometimes it's two, and then sometimes you get no possible. So this video will talk about all three situations and how you can tell which is which. So right now we have B, and so that would be make that one B. We're going to call this side, this angle A that we're looking for, and so that would be A there. So again, this is A, this is B, this is A, and this is B. And as you can tell so far, there are going to be two answers here because there are two situations where this can happen. So we start this the same way. This will be sine of B over little b, and sine of A over little a. So those ratios. And so we plug it in. This is sine of 30 over 10 equals sine of A over 15. So now when we cross multiply, we get 15 sine of 30 equals 10 sine of A. So it's just like before. You divide the 10, and so you get that situation. So now we have sine of A is equal to 15 sine of 30 over 10. Now the difference here now is we're actually going to be using an inverse sine. So inverse sine of 15 sine 30 over 10 would give us our A because we've got to switch them. We're being asked for the angle, so the arc sine of this would give us A. So now we're going to plug that in our calculator, and let's see what it gives us. Okay, so inverse sine of 15 sine of 30 divided by 10. Make sure our mode is in degrees. Nope, it's in radians. And then we hit enter. And there it is, 48. So our angle is 48.59. So we'll just say 48.6. So our A here is 48.6. 48.6 degrees. So that would be this one. This is 48.6 degrees. And so the way you have to think about this is this can make two different triangles. So this would be 48.6, and this would also be 48.6 degrees. So what that leaves us is this angle here for our other triangle. And if you notice, it is supplementary with that angle. So all we have to do now to make this one is take 180 and subtract the 48.6. So 180 take away 48.6 is 131.4 degrees. So that would make this angle here 131.4. So you notice we now have two triangles. We can find that missing C angle by taking these and subtracting 180, and we could take these two angles, which would be a total of 161.4, leaving us with 18.6 here for C. So you get two triangles. So anytime you can take that angle and subtract it from 180 and get an angle that works in the other triangle. So it's really quick. All you have to do is take the given angle, which is 30, add it to the 131.4, and if it's less than 180, it's a good angle. If it's not, it's not. So let's try one that's not. So right here. So now we do the same idea. We have beta, and we're looking for its opposite, which is 9. So if we take sine of 85 divided by 12, that would be the sine of beta divided by 9. And we do our same little multiplying. So sine of B, or beta, is 9 sine of 85 degrees over 12. Remember that little cross multiply thing up here, but it's basically just these two things divided. These two things multiplied it, and then divided by 12. You just put in the 9 over here. 9 goes there. That's it. So B would just be now the inverse sine of that. All right, so let's plug that in our calculator and see what we get. So inverse sine of 9 sine of 85 degrees divided by 12. Hit enter, and we get 48.34 again. So 48.3 degrees. So if we subtract that from here, we end up with 131.7 degrees. Now, how you can tell this is not a good angle, this 131.7, is if we were to plug it in here and we add them together with the 85, our interior angles already are over 200 degrees. We are at 216.7 degrees, which is greater than 180. That's not good. Which means we only have one triangle. So all you have to do is subtract that angle that you find from 180 and look at it. If it's bigger, if these two right here add up to something that's more than 180, you throw away the second one. If they don't, so like on that one before, we have 131.4 plus the given angle of 30. That's 161.4. That's less than 180. So that's good. Good, we keep it. All right, but to give you an idea of this, because you can't just look, oh, we do this, this, and this, and it works out perfect. Let's look at Desmos and see how this works. So I have our little first triangle we did. We have an angle of 30 here. And then the two sides that are given are here and here. See, there's the opposite and that opposite. So you can notice that our 10 here is actually less than 15, and that gave us two triangles. Those are the two that we get. We get that big one and the little one right here as well. So that big one and the little one. So this one and this one right here. So those are the two angles we get. All right, so what happens here is as long as this opposite side that we're given, so if this is our included, the angle that's given, the side that's opposite, as long as this is less than this one, you're going to be getting those two triangles. As soon as I make that angle bigger than 15, see, when it goes bigger than 15, it becomes one triangle. So this one's outside now. It's outside of it. So our angle of 30 doesn't work anymore. That little side has to be smaller. So as long as it's smaller than this one, this little leg here will fall within this triangle, giving us two different triangles. As soon as it hits 15, well, then that's one triangle. See, at 15, it's one. They're equal. Both sides are equal. Just force it to work. See, it's one triangle. And then as you go bigger, it's still one triangle. So that's the whole goal right here, is if that opposite side is smaller, we're going to get two. To a point. It can get too small, and what happens is you get this little thing, what I like to call the T-Rex effect. So those little arms are just too small. They can't connect to make a triangle. So if you make that opposite side too small, it cannot connect to make a triangle. So you get this situation going on. It has to be long enough to connect. See? Long enough to connect. But once it becomes bigger than the other side that's not the opposite, the adjacent side, it then becomes one triangle. So if this is bigger than this, we have one triangle. If it's less, then we have two triangles until a certain point when you get the T-Rex arms. It does that. Okay, so we're going to look at that now and see the different situations that happens. Okay, so that is why on the first one, if you notice 10 is bigger than 15, we got two triangles. And on this one, 12, the side that's opposite the 85, see? This number here is bigger than this one triangle. Okay, so you can look at it this way for our side-side angle triangles. These are the situations we have. So we're going to have a given side A, right, compared to sine A. And then we're going to have a given side B for the angle that we're trying to find. So that's what you want to look at. As long as the one that's given for the given angle is bigger than this one, you're going to get one. As soon as this one that's given for the given angle is smaller, you get two. So this situation. So we get those T-Rex arms. It's going to tell you because sine of B will be greater than 1. It's not going to work. Our A is actually less than our height is what happens. All right, if sine of B is equal to 1, this situation, you get a right triangle. So that means there's only one triangle. Now, if sine of B is less than 1, that's the whole key. It has to be that situation. That's no T-Rex arms. And A is equal to B, that's when we get our first one triangle. And then as long as that A, this guy right here, stays bigger than B, then you're going to get one triangle. Again, as long as the A is bigger than B, you get one triangle. And if the A is less than B, you get two. So that's all that it is. And again, once you plug it in up here, it'll tell you if it works or not. But again, you're focusing here. This is given, given, and given. And as this one's larger, that angle's larger. And so we get one triangle. If this one is smaller, then it's small enough to have two in there. So I like to think of it like little tiny things. If he's really little, he'll fit in two, right? So the given angle and the given side is small, then you're going to get two. If the given angle and given side is big, that extra arm is going to stick out way over here, so you can only get one triangle. All right, so let's take a look at these. So the first one now is no answer. That's the one we haven't done yet. And you don't really have to think about it. It's just sine A, right, over A. So that would be sine A over 2 is equal to sine of big B over B. And then you just solve it. So 6 sine of 30 degrees over 2 equals sine of B. And then we do B equals arc sine or inverse sine of 6 sine 30 degrees over 2. And then if you plug that in the calculator, you get error. That inside is actually 1.5. So this is giving us B equals the inverse sine of 1.5. That is not possible. Remember, our sine function can only go to 1 or negative 1. So it's this situation. See, sine of B is greater than 1. If you even look at it here, this is equal to 1.5. So that's how you can tell. And that's your three situations. There are no others because I've already shown you every single situation there is. So all you have to do is find one angle, plug it in with 180, and if that other angle works, then you keep it. And if it doesn't, you throw it away. And if your calculator says error, you say no solution. There's no answer. There's no value of B. This is an impossible triangle. All right, so let's try one now, just to see how it works. So we're given C, see? And so you can see now that C is big compared to B. So C is bigger than B, which means we're going to get that really long arm. There's only going to be one triangle. Okay, but even if you don't see that, you say sine of 67 is to 80.2, as sine of theta is to 56.3, and then you just solve it. 56.3 sine of 67 degrees over 80.2 equals sine theta, and then so now you just put the inverse sine in of this. So inverse sine of that massive thing. And that equals 40.25. So we'll say 40.3. And then again, if we check that, 180 minus 40.3 is 139.7. So if we try to make the 139.7 work, it'd be 139.7 plus the other angle that's given. And you can already see this is greater than 180. So we throw it away. So the only answer is 40.3. That's it. So that's your situation. You check the last one. If it works, you're good. If it doesn't, you don't. And then you can go to the Desmos graph that's in my website, and you can check it as well. So my angle is 67 degrees. The opposite side is 80.2. The opposite the angle we're trying to find is 56.3, and there it is, 40.25. And you can see the other one is just too long because this side is long. This other side would be long just like it, and it's going to be outside. So there you have it.